Mobility for commuting and logistics in varied geographies, from desert open plains to marshlands, dense forests and steep mountains, gets very difficult. For example, the people living in the mountainous region face the most complex geographical challenges due to diverse barriers, from tall ridges, rocky terrain and barren tracts, to alpine forests, glaciers and river gorges. MAST, that is Multidirectional Autonomous Suspended Transportation System, has applications in military, civilian and disaster management space. As a case in hand, although existing border infrastructure aims at providing workable connectivity, it is simply impossible to reach deep into the interior regions using vehicles. Quick deployment of troops, supplies, fuel and weapons are still very challenging. Constructing roads in such areas is nearly impossible. Brave soldiers most often have to move on foot with heavy gear or have to use animals like military mules, yaks and camels with local civilian guides. Ropeways or cable cars are widely used for transportation in hilly areas with difficult geography. However, ropeways have major disadvantages that prevent their ubiquitous use at our mountainous border frontiers. Firstly, ropeways require sizable end stations with huge machinery to pull cable cars. They have bulky cables and require large pillars for cable support. Secondly, they only provide transportation between two endpoints that are within the line of sight of each other. These factors lead to multiple issues such as rigid mobility, heavy construction, and maintenance requirements. In addition, damage to even one pillar completely cripples the ropeway system. Fenss Multidirectional Autonomous Suspended Transport. Applications of MAST system range from people transport in challenging terrain, logistical or supplies or drone transport, disaster management where people and goods can be moved in disaster-struck areas, dual-use infrastructure for the armed forces, automated surveillance, to applications that even cover rides at amusement parks and intra-city transportation. Disaster recovery solutions include rescuing people in flood-hit areas, mountainous areas, and delivering emergency supplies to stranded people. In this video, we will show dual-use examples for the armed forces. This patented technology deploys a fleet of autonomous transportation robots on an interconnected web of small cross-section lines and line changer hubs. Robots and line changer stations are powered via the lines, which eliminates the need for large batteries and increases payload capacity. Fiber optic network cables can also be embedded inside the lines, which can enable high-speed communication with remotest outposts. Additionally, heating coils can also be embedded inside the lines to prevent the accumulation of snow. As we will demo shortly, the MAST system will be able to deploy autonomous robots, each with a payload capacity of more than 1 ton, to multiple destinations that lie beyond the line of sight. MAST has patented mechanisms that sets it apart from conventional ropeways and cable cars. MAST robots can change their direction of travel by switching lines at line changer stations. Design innovations enable the robots to hold on to the suspended lines in the harshest of conditions and travel smoothly over the web-like network. MAST robots can climb at angles exceeding 45 degrees while maintaining a speed of 15 km per hour. In case of a low angle of climb, robot speed can exceed 15 km per hour. With a small cross-section and a web-like architecture, damage caused to any section of this infrastructure will not prevent transportation to any of the multiple destinations. MAST will provide the much-needed deep connectivity and enable transport of personnel, logistical operations, automated surveillance, and also ferry drones with maximum speed. In this demo, The mountainous terrain has 4 to 5 army base camps with B1, B2, B3, B4, B5, B6 as the stations for a network of changing pathways or lines. R1, R2, R3, R4 are the robots used for transportation between the network. If there is a river, gorge or valley, road may take 20 kilometers to take you to the other side, while MAST can take a straight route that is only 500 meters. Here, R1 is attached with a gondola carrying 2 passengers A and B from station NX. The drop-off point of A and B are different stations. The multi-lined Fenss robot drops off passenger A at station NV and passenger B at station NT without any layover with utmost safety and reliability. The spider web infrastructure enables MAST to effectively connect to the stations beyond the line of sight. The centrally administered fleet management system makes the Fenss robot fully automated with the least human intervention required. MAST has a multi-purpose utility and can be mounted with a sensor suite for surveillance and weather monitoring. Secured with avalanche protection, it safely carries heavy-duty goods over difficult terrain and reroutes pathways, which gives flexibility in case of attack, maintenance and breakdown. MAST can also be equipped with drone charging and reprogramming. The drone is released from robot R3 for surveillance. To mask its path, it is received and reprogrammed by another robot R4. The compact cross-section of the infrastructure makes it difficult for the enemy to target and attack. In case if one station is damaged under attack, the connectivity is recovered with the rerouting of the robots. The robots are clamped to the wires in such a way that they don't fall off even in the most extreme situations, making it sustainable for all weather conditions. MAST holds the potential to provide deep connectivity in difficult terrain and create a comprehensive, agile and robust transportation network with dual use. MAST will work in tandem with existing infrastructure to provide the armed forces an upper hand in challenging terrain.